Hello everyone. Let's provide the solution to this problem. We have 2 to the power of x plus 1 equals 3 to the power of x. Now, we cannot express 2 and 3 to have the same base. So what should we do? Okay, so this is the point where we take log of both sides. So we have log 2 to the power of x plus 1. And this will be equal to log 3 to the power of x. Now, what happens to the power? Remember, this power, they are both together, right? So we can now say that x plus 1 in brackets, then we have log 2 is equal to, the power goes behind, we have x log 3. Now, from here, what do we do? Since we are looking for the value of x, I can simply divide all through by x so that x will move to this place, right? So I can divide this by x and then divide this by x. This will move from here, and now we are having x plus 1 over x. Let's have this together. Then we have log 2. This is now equal to log 3. Now, what again will I do? At this point, I would have to take or divide everything by log 3. Sorry, we are dividing by log 2. So divide this by log 2. This is going to go with this. So now we have x plus 1 over x being equal to log 3 over log 2. Simple, isn't it? Now we have x together, and we have sorry, this is 1. We have x together, and we have logs together. Now we have x plus 1 over x being equal to log 3 is the same thing as 0.477 approximately, and log 2 is 0.301 approximately. So that from here we can divide this, by the way, or we cross multiply, but let's divide this. So we have x plus 1 over x being equal to, let's divide 0.477 by 0.301. Okay, so this is giving us 1.585 approximately. 1.585. So at this point, to get the value of x, we will now cross multiply again, so that x plus 1, okay, x plus 1 will be equal to 1.585x, because x is going to multiply that. Now what do? This is the point where we collect like terms. So we're going to have 1 to be equal to 1.585x minus this x will go there to become negative. So from here, what do? We have 1 here, which will be equal to, if you subtract this, 1.585x minus x will give us 0.585x. But remember that we are looking for the value of x. So we can divide this by 0.585, then divide this as well by 0.585. This is going to cancel this. And now our x will be equal to this. And it's 1 divided by 0.585. Okay, so after dividing, we are having approximately 1 1.709. So this becomes the value of x. But let's put it back into the equation and see if we are correct. Okay, so I want to put this value of x into the equation. So I have 2 to the power of 1.709 being equal to, or should this be equal to 3 to the power of 1.709? Now, this has to be added to 1. We need to add 1 to this because of that. Now, if you add this, you'll be having 2 to the power of 2.709. Should this be equal to 3 to the power of 1.709? Now, let's use calculator to imagine what we have on the right and on the left hand side. Okay, so this is what we have. Remember, we're having approximated figure. So on the left, we're having 6.53868. Then on the right, we're having 6.53733. So can we say that these are equal? We can say that they are approximately equal, because if I approximate this to two decimal places, right? So I'll be having 6.54. Okay, move 1 from here to make this 4, and it will now be equal to this when approximated to two decimal places. We'll have 6.54 as well, because you move 1 from here to get this one, 4. So this is to confirm that if we say x is equal to 1.709, we are very correct. Thank you for watching.